Welcome back. Today I have some awesome news. We might have a beta for you guys to test our CalVPN in like a week or two. Hopefully within a week. So I'm super pumped. If you want to come test it out for free, come get involved. It's super exciting. We're creating the first ever quantum proof VPN. And it's all going very well. The quantum algorithms are... Come have a read on my website, calvpn.com. Sign up there. It'll help me out a lot. But anyway, let's get into today's video. Today, we're going to be watching... what are we watching? Let me change this. There we are. You guessed it. More Kurzgesagt. And someone in the comments in the other video noted that this is a team. A German team. Well, obviously, they're German. But yeah, I guessed it was a team of like 20 people. And it is. And... these guys should be applauded and rewarded and whatever else. So go subscribe to them. Check them out. I love their videos. They're really entertaining and they're doing a great thing for our civilization, our society, the world. Just making science cooler, spreading the love. Let's watch this video. What if Earth got kicked out of the solar system? I need my earplug in. I'm all caffeinated up today, if you couldn't tell. Okay.
The night sky seems peaceful and orderly.
No, it does not.
But in reality, stars are careening through the galaxy at speeds of hundreds of thousands of kilometers per hour.
Black holes, man.
Not bound by static formations, but changing neighborhoods constantly. Fortunately, space is big, and so the stars of the Milky Way are very unlikely to hit us. Unfortunately, they don't have to hit anything to make us have a really bad time on Earth. And there are already stars starting to get very close.
Have you ever heard of those theories of like, I can't remember, it was 2012, remember that movie? And the whole sort of like Mayan mystique around it, wasn't it? Some people were claiming, you know, that they were predicting, you know, the star was going to come into our system and, you know, knock everything around and cause mayhem. I don't know too much about that, so maybe someone can educate me on the conspiracies around that in the comment section down under.
To understand how dangerous stars are to us, we need to talk about gravity. Gravity attracts every piece of matter to every other piece of matter in the universe. You are attracted by an atom a million light years away and vice versa. Luckily, this force gets weaker over distance, and it also depends on how massive something is. So things that are close and are very massive are more attractive, winning the cosmic tug of war. This way, massive things define how smaller things behave around them.
So that,
the sun makes up...
I'm not sure if he's going to go into it, but just we've talked about it too much already. But like, obviously, that's not really how gravity works. You know, there's a deeper level to that, which is Einsteinian gravity, which is just, you know, gravity is the curvature of space-time itself, and so it's not really that things have a attraction to each other. You know, if something comes within the curved space-time, it's going to follow the geodesic, the curved space-time, which, you know, warps it usually towards the more massive object. But anyway.
99.75% of all the mass in the solar system, and so it shapes the behavior and orbits of everything else in it. Billions of years ago, after the sun was born, the solar system was a chaotic and dangerous place as the planets were formed from countless little pieces that collided constantly. But over the eons, a stable balance emerged. Today, most planets and asteroids have settled into safe and predictable orbits. We have the inner and outer planets, the asteroid and Kuiper belt, and at the edge, the Oort cloud, a giant sphere of comets orbiting slowly in cold storage.
Yeah.
We really don't want this balance to be disturbed.
The Oort cloud is super mysterious. We've talked about it a lot as well, but it's, you know, it is still somewhat theoretical, and you know, it's like a quarter of the way to the nearest star.
If another star came too close to us, its gravity would pull on everything in the solar system like a spoiled toddler, messing up the pleasant order of the planets and asteroids and comets. This isn't some imaginary danger. Some 70,000 years ago, a red dwarf-brown dwarf binary system passed through the Oort cloud and messed things up. It might even have sent a deadly onslaught of asteroids our way. But it could take 2 million years until those visitors from the Oort cloud arrive in the inner solar system. But there's a much bigger problem on the horizon. Gliese 710, a red dwarf with about half the mass of the Sun, is currently headed towards the solar system. In about a million years, it'll pass through the Oort cloud and become the brightest star in the night sky. A close flyby like this would unfold over hundreds of thousands of years, disrupting the orbits of millions of objects in the Oort cloud considerably. If we're unlucky, it will trigger a new period of planetary bombardment similar to the early solar system. The night sky could be filled with comets and asteroids raining down on the inner solar system. The larger ones could cause dinosaur-level mass extinctions and would be bad for the stock market. But it could get much worse.
Yeah, so that Gliese 710 star is coming, and it's been estimated that it's gonna, possibly launch about 10 million objects at us. That's not too bad. Could be worse. And hopefully, Jupiter does its damn job and hoovers up all of that junk, because that's what it's done in the past. There's a good argument to be made that if life's going to arise in a star system, you need a big daddy like Jupiter to hoover up a lot of the big comets and asteroids. Otherwise, there's a constant bombardment on the planet. So Jupiter will likely protect us from a lot of those, but it only takes one big rock to launch us back to the Stone Age. So it's going to happen in about 1.3 million years. So prepare. I guess we should, maybe start preparing. The story behind how they discovered the Schultz star had, a close encounter of the stellar kind back in the day is actually pretty fun. It's somewhat like a movie. Hollywood, they discover it, and 5 minutes later, it's like, we're doomed. Because that's kind of what happened with this star. This guy was doing these excursions to Chile every year. It's, famous astronomer. And, looking through these incredible telescopes. And one year, this other astronomer showed him a peculiar result, which was like the star didn't seem to be moving at all, because it didn't seem to have any sideways motion. Usually when you look at stars in the sky, they have noticeable sideways motion. This is called arc length. And this one seemed to be just sitting still. So it either means it's coming straight for us, or it's heading straight away from us. And it's only about 22 light away as well, which is interesting. And so they did a calculation in about 15 minutes and realized this thing was heading away from us at about 80 kilometers per second. So absolutely zooming and straight away from us. So that means, in about 15 minutes, they figured this thing would have passed like really close to us. And it turned out to be about, a light year. So that is very close, because it would have launched a bunch of objects at us. And like Kurzgesagt said, it can take a long time for those objects so far out to get to us. We could just be sitting ducks waiting for these things to arrive. I wonder what that would have been like for the hominins and, other humans around at that time, because, they were definitely, we know they were average, and he's up till about, even probably further back than 80,000 years. And so it would have been a very interesting time to be alive. With this thing that would have been very visible in the sky. That could be another fun movie plot.
Galaxy is an intense place,
that was a great joke.
And stars get close to each other regularly. So it is possible that a star could come much closer and not just pass us, but fly directly through the inner solar system. This would be very bad in the extreme. The chance of another star colliding with the Sun is astronomically unlikely, but that isn't what we're worried about. If another star were to pass by about as close as the Earth is from the Sun, it could easily eject the Earth from the solar system. The odds of such an event are estimated to be around 1 in 100,000 in the next 5 billion years.
It's really not that low.
Small, but not absurdly so. As we discussed in another video, there seem to be billions of rogue planets doing their own thing in the galaxy, and this is one way to make them.
So if you think there's probably not many of these like rogue planets around, well, there's actually been simulations to show that there could be about 50 billion rogue planets in our Milky Way alone, just doing whatever the hell they want. It's crazy. And if you think these rogue planets are the loneliest planets there are, well, you'd be wrong. You can now imagine rogue intergalactic planets. And if you didn't know, galaxies are somewhat like islands, little islands in an ocean. It's a pretty good analogy. And imagine what the sky would look like to these rogue planets, that are just like in between galaxies. It would be crazy. Like, you would have these little patches, small patches of galaxies, and then there'd just be blackness mostly. You wouldn't have stars in the sky, really. Because, in our night sky, we can only see a couple galaxies. You've got Andromeda there, but it's tiny. It's like not too much bigger than a full moon in the sky. I think it's like, what is it, like 5 times size? But it's just blowing my mind thinking about what the sky would look like to these intergalactic rogue planets. That would be a lonely place. Yeah. There's really not much you could imagine life arising there. You're pretty much stuffed. That's possibly the loneliest place in the universe. I should also state, though, we really don't have a good idea of how many rogue planets there are because, they're incredibly hard to detect, and a lot of people think we just won't be able to detect many of them at all. So it's really hard to give an accurate estimate because, simulations are just computer simulations. They can help inform us, but they might be completely wrong. So take it with a grain of salt. It's interesting to think about. But yeah, that is the perfect horror movie plot. Exploring this rogue planet, and it's dark. It's got this evil, scary looking life. It's like Alien on steroids. That would be the stuff of nightmares. Someone should write that.
So if this were to happen with an average red dwarf, what would happen on Earth? Kicking Earth out of the solar system. As the star enters the solar system, a small orangish dot appears in the sky that grows bigger and bigger for months, eventually becoming visible during the day. It would get bigger and much brighter than the moon. Too bright to look at directly. The night sky would be filled with an eerie red glow. After a few months, it would start shrinking again. But so would the sun. Over a few years, the sun slowly grows smaller in the sky, and with it warmth and light start to dissipate. All around the world, as the days turn dark, the final winter of humanity would begin. The polar ice caps begin to grow and spread while plants shrivel and die. Forests freeze and animals die in droves. As the Earth passes the orbit of Mars, the average surface temperature has plummeted to near minus 50 degrees Celsius. From space, Earth begins to look like
I know someone that went for a bicycle ride in like Siberia, like that remote area of Russia, and it was like negative 60 degrees. And they were riding along. I can't remember how big the ride was, but it was a big ride. Why? I don't know. But he was telling me how there was a group of these guys, and they all wore balaclavas, because it's that cold. And I was just laughing hysterically for ages, just imagining a group of bicycle riders riding along wearing balaclavas. That's apparently the norm in Russia. So.
An icy moon, the blue-green surface becoming the pale grey-white of death. As global infrastructure breaks down, people huddle together indoors, burning what they can for warmth as the temperature continues to drop, counting the days until they'll be out of food which no longer grows. Everybody living at the surface is living on borrowed time. By the time Earth reaches Jupiter's orbit, surface temperatures sink to minus 150 degrees Celsius, lower than the coldest ever recorded temperatures in Antarctica. Needless to say, by now, almost everyone is dead.
Yeah.
Without the energy from sunlight to evaporate water, clouds don't form and the water cycle stops. The polar ice caps eventually touch at the equator and the oceans become covered in a thick layer of ice. As more and more of its heat leaks out, more water freezes onto the bottom.
This just got very depressing. But yeah, how interesting is this? You still have an ocean down there, and it might stay relatively warm because there'll still be plenty of activity in the core of the Earth, and around those hydrothermal vents where we think life may have begun. And you might have heard of Europa, a moon within our solar system. It might have life underneath the. We think it's got this layer of ice on top of it, and there's some evidence to suggest that it is a layer of ice because it's cracking and there's plumes of water, and we've launched not yet. There's a NASA mission. What is it called? Clipper, Europa Clipper, and it's gonna fly around, orbit Europa and sample the plumes that launch out into its little atmosphere. And we'll be able to, sample what the water is like underneath that icy layer on Europa. because we're curious. Maybe life is down there. Maybe there's some hydrothermal vents down there, and they've been there for a long time. Just causing, sparking life. And because it orbits Jupiter, might be, there's some gravitational tugging there. So that can, cause those ice sheets to move around as well. And, that creates friction for the ocean, creates some warmth, and there's other ways that, it can keep Europa warm as well. So it's all very interesting. I can't wait for us to visit Europa. And then beyond Europa Clipper, I think they're going to try and send out something to dig down and see what's down there. Can you imagine if we, got over there and there's just like octopi floating under there?
Of the ice sheet, the concentration of salt in the deep ocean grows, poisoning most animals that survived here. Yep. Although around hydrothermal vents, communities of extremophiles might adapt even to these circumstances. Deep below the surface, some bacteria would not notice much of any of this, as they're still kept warm by the radioactive decay of elements in the Earth's core.
Yeah.
As the Earth reaches the orbit of Pluto and the Kuiper Belt, the Sun is still the brightest star in the sky, but it's one among many, with stars now visible during the day. The temperature is now barely 40 degrees Celsius above absolute zero, below the freezing temperature of the gases in the atmosphere. A weird spectacle, enjoyed by no one unfortunately, unfolds as the atmosphere turns into nitrogen and then oxygen snow. Over a few years, it's deposited into an icy 10-meter thick sheet all over the planet's surface, with only a thin
what's crazy? You might be watching this thinking, oh yeah, this is like some nice sci-fi story. Stuff like this is possible, man. And it'll likely one day unfold. I don't mean this exact scenario, but things equally as terrifying. If you didn't know, the sun is expanding, getting hotter. Oceans are going to evaporate eventually. So terrifying, hellish environments like this are inevitable in our future. We need to get off this rock.
Of gas remaining.
Or figure out ways to...
The frozen corpses of flora and fauna are buried beneath them. As Earth leaves the solar system, it becomes a rogue planet, traveling alone through the dark, lifeless and in solitude. But weirdly enough, there is hope. Humanity would not be surprised by this potential extinction event. We'd notice it thousands of years in advance. There's not a lot we could do to stop a star, but we could prepare. Most of us would perish, but a few million could survive in huge artificial complexes powered by geothermal and nuclear energy, possibly even fusion if we can learn to use the ice around us for power.
I was going to speculate on this because I wasn't sure if he was going to go there, but I was going to say, yeah, people could definitely survive into these futures, especially if we unlock fusion, because that's what's happening in the stars. There's lots of hydrogen around. We'd be able to keep ourselves warm essentially by creating a little miniature star, especially if we could contain it properly. Yeah, I think people could survive. So fusion is the key.
Here, humanity might survive for hundreds of thousands of years.
I was actually reading some really cool news recently, how some simulations have been done to show that rogue planets, if they have the right atmospheric conditions, if they've managed to retain some of their primordial atmosphere with enough hydrogen and helium in it and greenhouse gases, it might be thick enough, you're talking like 100 times thicker than Earth's, to harbor liquid water still on the surface for billions of years, and even potentially life. So that's good news, so don't, and it looks like we could be heading into a runaway greenhouse effect on our planet. So then if, a star comes past, knocks us out, well, that could actually play into our favor. I'm just completely this crazy speculation, but, always look on the bright side of life. There might not be much brightness around with no stellar light, but at least, there'll be water. The reason why the atmosphere would need to be about 100 times thicker is because that would increase the pressure on the surface and, sustain temperature. It wouldn't fluctuate too much. And the view would be like a very foggy day. And the temperature would be pretty steady, but life would probably be pretty slow. And we do know there's some bacteria on Earth that, can thrive with just helium and hydrogen rather than nitrogen and oxygen. So, interesting stuff. And we still don't know if the presence of water leads to life. But I would wager that wherever we find liquid water, you know, wherever it is, I think we'll find life. That's my, you know, insight for you there. I think that's what's going to happen. We're going to find liquid water and life as we know it. That's what I mean. I think there'll be other kinds of life for sure. But life as we know it, I think wherever there's water, there's going to be life. Maybe very simple life, you know. But eukaryotic life seems to be, multicellular life seems to be way more complex. And it seemed to it took a long time on Earth. You know, prokaryotic life arose almost as soon as it was able to. But then to get to multicellular life, even how that process happens, we still don't understand. It's pretty incredible. And it took a long time. So maybe that's the real sort of, you know, one of those big steps, you know, things that we overcame on this planet and got lucky. So you might be wondering, how would a rogue planet, you know, be ejected from the galaxy? Well, I can think of 3 good ways. And it wouldn't be too much harder than, you know, a star getting ejected. Maybe harder in some ways, but, you know, you have tidal interactions of galaxies, which, you know, they rip out a large number of stars from the galaxies and fling them out. You could have 3-body interactions, probably with supermassive black holes, which can result in like a hypervelocity. You know, it can pretty much, it can fling stars out at like hundreds of kilometers per second, which, you know, as much as like 800. Then there's supernova, which are like asymmetric. So, you know, that can give a kick to the resulting neutron star that's left and just launch it. I think we've measured some at like 1500 kilometers per second. So they're just careening. So that's how stars are ejected from galaxies. The first one applies equally to rogue planets. Number 3, the supernova, that doesn't really work. Number 2, it's a lot less applicable, you know, but you can just get stars that have been launched out there. I should say, because it's hard to get 3-body interactions through ones with planets. But if you just got a rogue star, and, you know, planets can be ejected based on what Kurzgesagt was talking about. You know, you can get interactions with the solar system planets, you know, launch a planet out.
At some point, we would become used to
And, you know, there's another alternative as well. What happens if we do shed our biological meat shacks, you know, become some next level, you know, life form, you know, inhabits like a robotic form, you know, without consciousness in there. Well, it won't matter too much if it gets cold, you know. So there's that outcome as well. Or, you know, it's just AI. AI's destroyed us, and it can just do whatever it wants.
And new generations would watch documentaries in disbelief about the time we had our own star and could walk the surface of Earth. And at some point, we might decide to look for another home. If the Earth were lucky enough to pass by another star with a habitable planet, we could try to make a fresh start. Spaceflight, oddly enough, would become very easy without the atmosphere in the way. So it's not unthinkable that the last survivors would leave Earth behind and try again on a new planet around a new star.
For sure.
Maybe one day, thousands of years later, the descendants of humanity will tell legends about Earth's ancient past. Stories of our lost home, of a mysterious icy planet, floating alone and empty through the dark of space.
It's a good movie plot, isn't it? Let's check out these comments. Kurzgesagt is here. Welcome to the future. I'm filming this the day after I just filmed this video, and I was reading some really interesting news last night that was relevant. And apparently, if a star wanders too close, or just a general star, you know, flying past our system, it could actually cause our solar system to collapse, apparently. So there was some work done, and in these simulations, apparently if Neptune's orbit is shifted just by 0.1%, some serious shit might go down. If you want to know what that sort of stuff is, come watch my next video, this one that I'm filming now, because I'll explain and talk about it a bit more, as it's a bit more relevant to what I'm watching right now. To remind us that 2020 will not be the worst year in human history, and I'm strangely grateful. Yeah, we don't appreciate how good we've got it. That's for sure. The best part of this scenario is that for once, it won't be our fault. Climate change, my man. We probably won't even make it that far. The amount of realities that can be created from the tiniest shifts in space are phenomenal. Indeed, my friend. I want a TV series about this. I want a season for each stage. That would be awesome. Dinosaur-level mass extinctions, and would be bad for the stock market. Yeah, that was my favorite joke in all of his videos thus far. This could be terrible for the economy. There are already stars coming closer. God damn, already giving me an existential crisis. Yeah, like 30 seconds in. Just hearing Earth being referred to as a rogue planet sends shivers down my spine. Yeah, makes me think of Rogue One by Star Wars. That epic final scene with Vader. You guys watch Obi-Wan? So good. Thanks for a great channel. Yep, thank you, guys. The larger ones could cause dinosaur-level mass extinction and would be bad for the... Oh, okay, I should have caught on. Bum, ba, bum, ba, bum. It would become easier to do spaceflight with no atmosphere. This, or similar sentence, got me thinking that would the satellite, debris, and other space junk continue to orbit Earth even if Earth went rogue, or would the gravity of some other passing by object... Yeah, no. There would be all sorts of gravitational perturbations that cause them to, you know, sink, or not sink, just destabilize the geospatial orbit, and just leave us as well. They'd become rogue satellites, a bit like Voyager, out there to float endlessly, frozen in time. What else have we got? I'm looking for questions. Here we go. The thought I had when watching this: what if alien civilizations do exist? Of course they do. And they built their own forms of cities on their planets. Then this happened to them. If humanity ever manages to travel to other planets outside of our solar system, might we discover remains of alien infrastructure that went through this process? Absolutely, my friend. If you want a fun little story about this, a short story, check out Arthur C. Clarke's The Star. You can listen to it, and there's an audio version of it on YouTube. Brilliant. These advanced, you know, humans are exploring another star system, and on the outermost planet, like a Pluto, they find something, and it's somewhat of a, you know, a last sanctuary of their species. They knew their star, I think, was going to go supernova, and so they create, like, you know, this testament to what they were, as kind of like a, you know, I don't know, a beacon. It's so beautiful. Go check it out. I think it would be a great movie. Maybe one day, thousands of years later, Senate's humanity will tell the legends. Yes. Wouldn't that be cool? I can't describe the feeling. Any more questions? Questions? What would have happened to the satellites in this scenario? Okay, we already talked about that. Anyone got any other questions out there?